So let us revise what we have done in first lecture. We started with giving names to numbers. What were names to numbers? Natural numbers. Natural numbers are 1, 2, 3, 4, 5, 20, 90, 100. It should be positive. Also, it should not include 0. Negative will not be. Natural numbers, then whole numbers. Same as natural number, but includes 0. Minus is not included, right? Third is integers, right? It includes a negative, minus 3, minus 5. It includes 0. It includes what it does not include, 3.25, minus 3.25. Then non-integers. What are non-integers? 3.25, 9.85, minus 3.256, minus 9.2895, and so on. Is 0 a non-integer? No. Right, 0 is a integer, right? It is not a non-integer. So integers and non-integers are mutually exclusive. A thing which is an integer cannot be a non-integer. A thing which is non-integer cannot be an integer. So 0 can be either integer or it can be either non-integer. So 0 is an integer. After integer, non-integer, we did rational numbers. It includes everything. Minus, that is negative 3.25, negative 3. It includes a 0. It includes a positive 4.25, positive 4. But it does not include irrational. So to understand irrational numbers, we also learned what are irrational numbers. The numbers which goes on continuing, which never ends. 3.3333333 never ends. 22 divided by 7, which is also pi. And mathematical, these all are irrational numbers. Then we went to real numbers. So we have understood rational, right? Rational are anything which is not irrational. Real numbers includes rational. See, rational included everything except irrational. But real includes a rational as well as irrational. So all numbers are real numbers and our chapter's name is even real numbers. After learning this numbers, we went to two main things which are important for learning chapter number 1, that is real number, which is prime number and once again let me revise it. What are prime numbers? Suppose a number, say any number, will always be in a table of 1. How? 1 5s are 5, and will be of table of itself. That is 5 1s are. So any number, you take any positive numbers, it will always be in one table, and it will always be in table of itself. If it is not in any other table, then this number is a prime number. 5 is a prime number. It will not be in a table of 2, it will not be in a table of 3, it will not be in table of 4. Of course, it will not be in table of 6, 7, 8, 9, 10 because they are greater than it. So, it is not in any other table. Means the product, the multiplier is except 5 and 1. Then it is a composite number. If it is only itself and 1, then it is a prime number. Let me take 4. See again, as I told you, it will always be in a table of 1. It will always be in a table of itself. Is it in any other table also? Yes. 2 2s are 4. Then 4 is not a prime number, it is a right. Once again, 6. It will always be in a table of 1. It will always be in a table of 6. Is it in any other table? Yes, it is in a table of 2 also. It is in a table of 3 also. But that is not important in how many tables it is. Even if it is in one more table, then it is a composite number. Right. So here you don't have to list that in how many tables it is coming. Even if it is coming in one more table, except 1 and except itself, then it is a composite number. If it is not coming, 7 comes in one table, 7 comes in 7 table. It does not come in any other table. 7 is a right. Similarly, 9, no. 9 is a composite number, right? 1 9s are 9, 1 9 1s are 9, 3 3s are 9. So it is coming in table of 3, right? Then it is a composite number, right? So the difference between prime and composite should be absolutely clear. What are prime numbers? What are composite numbers? Can you help me out? 11. Ishwa?
Yes. Prime number.
It is a right. So what we'll be doing? We know the logic, right, of prime numbers, but we will also try to remember prime between 1 to 30. Today we will be going only for 1 to 30. Tomorrow we will be going 30 to 60, and day after tomorrow we will be going from 60 to 100, so that we get the idea of which are the prime numbers between 1 to 100. So 1, please understand, 1 is neither prime nor composite number. Right. So 1 is defined as 1. 1 is not treated even prime, 1 is not treated even composite. Right. Exactly. So it is only in one table. Prime number normally are in 2 tables. Right. So mathematically it is told that 1 is not a prime number. Neither prime nor composite. We are going to write only prime. 2 is a prime number, yes. Yesterday I told you 2 is only even prime number. Other all even number will be composite number because they will be divisible by 2, right? It will always, all even number will be in the table of 2. So only even number which is a prime, which is 2. 3 is a prime. 4 cannot be prime, right? Because it is a even number. It will be in a table of 2. So 5 is a prime. 6 cannot be prime. 7 is a prime. 8, 9. 9 will not be a prime, right? 3 3s are 9. 10 even number, so we are going out. 11 will be prime. 12 cannot be prime. 13 will be prime. 15 will not be a prime. 3 5s are 15. 5 3s are 15. So 15 is not a prime. 16 cannot be prime. 17 is a prime. 18 cannot be prime. 18 cannot be prime, right? It is even number. Even numbers are 2, 4, 6, 8, 10. These all are even numbers. Even number cannot be prime except 2. So 18 cannot be prime. 19 is a prime number. 20 cannot be prime. 21. 7 3s are 21. Right? So it cannot, 22 cannot be prime. 23 is a prime. Right? 25 cannot be a prime. See, anything in a line of even 5, 5, 10, 15, 20, 25, we know it will be in a table of 5. So it cannot be prime, right? 26 cannot be prime. 27. Exactly. It is not a prime. 29. 30 cannot be prime. Right. So 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. In 2's line there are only 2, 23 and 29. In 1's line 11, 13, 17 and 19. In 0's line 2, 3, 5 and 7. Right. 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. These are prime numbers. Alright. After learning clearly the difference between prime number and composite number, let us understand one basic rule of algebra. Sorry, not algebra, it is arithmetic. Let us learn basic principle of arithmetic. Fundamental, very basic principle of arithmetic. It is even a basic principle of maths, and it is a magic. What is a magic? What does this rule says? Understand. Any composite number let me start with the smallest composite number, which is 4. Right? 4 is a composite number. Right? How it can be determined as a product of some number means 4 can be is equal to 2 into 2. Right? Believe me, this 2 is a prime, even this 2 is a prime. What is the rule says? We'll also repeat it. Any composite number is a product of prime number. When I say product, means multiplication, right? Product means multiplication. Any composite number, I am not talking only about 4. Any composite number will be multiplication, product of prime numbers. Let me try out. 5 is prime. 6 is a composite number, right?
Yes.
It is 2 into 3. See, 2 and 3 both are prime numbers.
And
2 and 3 both are prime numbers.
Prime.
Let me try out with next. 8. 2, 2s are 4, 2s are 8. Right? Why I am not writing 4 into 2? Because I know 4 is a composite number. I want only prime numbers on this side. Right? On purple side, I want only prime numbers. I could have written this 4 into 2. Right? But here 4 is a composite. Right? I want all prime numbers. So I have written 2 into 2 into 2, which is 8. See these numbers. These are prime numbers. 2 and 2 is a prime number. Right? Any composite number will always be a product of prime numbers. Will always be a product of prime numbers. Let me take a big number. Now I am not going in sequence. Say 20. Right? See how to do it. You will have to do it on your own. 2 multiplied by. Now we have taken 2. So 2 tens are 20. What is remainder is 10. Right? Now we need, once I multiply 2, what is remaining is 10. 2 2s are 4. Right? Multiplied by. 2 3s are 6. I should not do that, right? I should not multiply 2 once again. Why? Now the answer will be 6. And 6 multiplied by anything is not 20. Right? So 4 multiplied by how much is 20? 4
Pfizer.
5s are. See the magic happened. 2 is prime. 2 is prime. 5 is also prime. Alright. Let me take another page also and let us practice it. Prime numbers. Composite number. Right. Let me take one more composite number. 30. I am doing the product of 2. Right. See, always you should do this. When I do 2, 30 divided by 2, what will be the answer? Remainder is 15. Right. So now whatever I write down, the answer of this 2 should be 15. Right. So 15 2s are 30. So this 2 answer should be 15. Right. So what is the answer of 15? The 2 table does not consist the answer 15. So what I'll write down? 2 3s are 6. 6 5s are 30. Or I know this answer is 15, right? So I can directly write down 5 3s are 15. See, this answer is 15 because we have already multiplied 2. So 15 2s are 30. So now I want only answer of 15. So I am doing 3 into 5. Again, magic happened. 2 is prime. 3 is prime. 5 is prime. Right? Let me take an easy one. 25. It will not be in the table of 2, right? 5. 5 is prime. 5 is Prime.
Prime number.
Any composite number will be product of prime numbers. Any composite number will be product. Product means multiplication of prime numbers. You take any in this world, it will be product of prime numbers. Let me take this 120. See, I am also explaining how to do it. 2 120 divided by 2 is 60. Now remainder is 60, right? I can easily divide once again 2. So divided by 2, what is remaining is 30. Is it all right? 30 we know the factor. 2 into 3 into 5. So one more 2, one more 3, one more 5. Right? Now I am also teaching you how to write it down differently. 2 is how many times? 3 times. So write down 2 raised to 3, right? 3 raised to 1 because 3 is only one time. And 5 raised to 1. Still, all are which numbers? Prime numbers. All are which numbers? Prime numbers. Let me take one more and let us end this concept of arithmetic. 42. 42 is even number and it will be a composite number, right? If it is even number, your answer will always start with 2, right? Because it is easily divisible by 2. So 42 divided by 2 is 21. Into 3 into
7.
Right? We know 7 3s are 21, right? 2 is prime, 3 is prime, 7 is prime. Right. Let's take one more, last. 46. It is even. So 46 divided by 2, 2 will be our first answer. 2 multiplied by, answer is 23. See, this is why knowing prime numbers orally means without thinking it is important. 23 itself is a prime number. So there will be directly answer 23. 2 into 23. Again that magic happened. This both are which numbers?
Prime number.
Prime number. Right. Let me exactly write down the theorem. You don't need to mug up the theorem, but let me write down the exact what one of the mathematician Lucid has written. Every composite number the rule goes like this. Every composite number can be expressed as product. Ishwa, what is product? Multiplication, right? As a product of primes. And this is unique except order. Please understand, I have already explained you this. Every composite numbers can be expressed as a multiplication of primes. This we have explained, right? This I have explained. We have done it n number of times. That every composite number can be expressed as a multiplication of prime. Let me also explain you this. This is unique except order. Right. Let me take a prime number which is 21. 2 will not be a factor. Right. Factor means the number which I am writing it over here. 2 will not be a factor. What will be answer? 3 into 7. 3 is prime. 7 is prime. 21 is. We have learned this first part of the rule. Every composite number is having product of prime. Now let us understand this. This is unique. Means you cannot write down anything over here except this. Right? You cannot write down 2 into 6 into something and the answer will be 21. You cannot write down 3 into 7 into something and the answer will be 46. This will always be same. See here, what is 42? 2 into 3 into 7. This is unique. You cannot write down other prime numbers and get answer 42. Yes, you can write down other composite number and get answer 42. How I'll tell you? 2 into 21. But here 21 is not a prime. 21 is a 7 3s are 21. It is a composite number, right? So if you write down primes over here, your answer will match with all other students' answer, will match with all other persons in the world. So what does the rule says? This is unique. There is no other combinations. Except order. Order means 21 can be denoted as 7 into 3, right? So it can be 7 into 3, it can be 3 into 7. But if you forget order, if you think that 3 into 7 and 7 into 3 is the same number, then the combination will be unique. Here also, please understand. Here it was 2 into 23. We can write it down 23 into 2 will be 46, right? But except order, you cannot write down 2 into 7 into something which will be the answer 40, right? So this is fundamental principle of arithmetic which we need to understand if we want to go ahead in mathematics. This is very useful, and what we'll be doing now is we will be just practicing this rule. We know the rule. Every composite number is a multiplication or is a product or is a factorization. Everything means the same thing of different prime numbers. This combination is unique except order. So if you think 7 into 3 and 3 into 7 is same, then the combination or the answer will always be unique. Let us take a prime which is 60, right? So now we will practice this. What we are going to learn ahead, this is important for doing it. We will factorize it. Sorry, 60 is not a prime. 60 cannot be prime. It is even number, right? It will always be composite. Factorize it in prime. 2. What is remaining? 30, right? 30 to 15. 15, we know the factorization. 5 into 3, right? Instead of 5 into 3, I am writing 3 into 5. Right? Again a rule. Every composite number will be multiplication of prime numbers, and this combination will be unique. There is no other combination where answer of the primes will be is equal to 60 except 2, 2, 3 and 5. 2 multiplied by 2 multiplied by 3 multiplied by, yes, order can change. So 5 multiplied by 2 multiplied by 2 multiplied by 3 is also 60. But otherwise this is unique, right? So now we will also learn how to write down this. 2 raised to how much I should write down, Ishwa? 2 raised to 2 is how many times? 2 times, so 2 square multiplied by 3 raised to 1 multiplied by 5 raised to 1 is equal to, you should try out this on your own, 30. Tell me. Alright, so everything is repeated one time, so I am writing down this, right? Raised to 1, raised to 1, raised to 1. 15. Tell me orally. 3 5s are, yes, 5 3s are. Raised to 1, raised to 1. So small numbers will now be easy, right? It will not be much difficult. Let us try out 90. See how I do it. 2. Remainder will be 45. Divided by 2 is always half, and half of 90 is 45, right? Once 45 comes, now I will not write down 3, right? Sorry, 2, because I know it is odd number. 2 is written only when there is a even number, right? So 2 multiplied by, now what is remaining? 45. 45 comes in a table of 5. 5 nines are 45, right? So I know the answer is 5 nines are, but 9 is not a prime number. 9 is a composite number. How it is a composite number? 3 3s are 9. So I know 9, 5s are 45, 2s are 90. How I will write down? 2 raised to 1, 5 raised to 1, 3 raised to, you should speak 3 square or 3 raised to 2, right? Alright, last 150. 2, what is remainder? 75. Believe me, 150 divided by 2 will be 70. 75 always comes in a table of 5, right? It will be 15 5s are. 15 5s are is 75. Yes, 5 multiplied by 15. Now 15 is composite, right? So factorize 15. We all 3 multiplied by, on left hand side over here you cannot write down any composite number, right? You will have to write down prime numbers. 2 raised to 1, 5 square, 3 raised to 1 is equal to 1. This is fundamental principle. Minimum 30 to 40 sums you should do. Take a composite number, factorize into prime numbers. Take a composite number, factorize into prime numbers. Try to practice it 25-30 times, right? Alright. Now let me take two numbers which are composite numbers. 20 and 15. Both are composite numbers, right? Let me factorize it by our basic principle of arithmetic. 2, 2s are 4, 5s are 20. What is the answer? 2 square, 5 raised to. Let us factorize this. We know this, right? 15. 3, 5. Right? 3 raised to 1, 5 raised to
1.
right. Which are the two numbers? 20 and 15. Right. Someone asked me, what is highest common factor between the number 20 and 15? Right? What is HCF? Highest
Height.
common factor. Sir, why to find out what is highest common factor? That I'll explain you. There are n numbers of uses to find out highest common factor. But let us first understand how to find out highest common factor. Right? As the name suggests, first, which is the highest factor? Now, what is factor? I'll tell you. 2 is a factor. 5 is a factor. 3 is a factor. 5 is a factor. Right? For what is the name of it? Factor. What are the factors? 2, 5, 3 and 5. In both the numbers. Which numbers? 20 and 50. Sorry. What is... There are two highest factors, right? Sorry. Alright. So, let us go to common. What are factors of 20? 2 and 5? You should not speak 2 square. 2 square is a number. Factor is 2. Right? So, 2 and 5 are factor of 20. 3 and 5 are factor of 50. Which is common factor? 5. Which is common in both? 5. See, 2 is over here, but it is not over here. 3 is over here, but it is not over here. 5 is over here also, and 5 is over here also. So it is known as common number, right? So 5 is a common factor. Right? Right. All right. Which 5 I should take? Please concentrate. Should I take this 5? Should I take this 5? In this question, there is no problem. Why? Because this number and this number are same. Now I am not saying factor, I am saying number. 5 raised to 1 and 5 raised to 1 is same. But suppose this was a 5 square and suppose this was a 5 cube. Right? Which is highest common factor? Try to understand. 5 is a common factor that we know. Now what word is written? Highest. પણ નાના છોકરા જેવું કરવાનું. હાઈ કે તો લો લેવાનું ને લો કે તો હાઈ લેવાનું. આમાં કોનું ઇન્ડેક્સ હાયર છે? This કોનું lower છે? Then 5 square is a highest common factor. Right? Name is having a problem, but I'll tell you why the name is given highest common factor. But right now our objective is to find out, is to calculate what is highest common factor. In this question there is no problem. Why there is no problem? Because both is having 1. So you take higher, lower, it does not make any difference because they are equal. So what is highest common factor? 5 raised to 1 is equal to. So what if someone asks me what is HCF between 20 and 15? It is. Right. Let us go to next. What is LCM between 20 and 15? Now let me first of this, what we have drawn for. Again, my target is to first understand how to find out. Then I will explain you why we are finding out, right? So our target first we need to satisfy how to find out. For LCM, take all the factors. Which are all the factors? 2, 5, 3 and 5. If it is common, it is just a factor. So how many factors are there? 2, 3 and 5. Right. LCM full form is lowest common multiplier. Believe me, multiplier is same as factor. But in LCM, instead of LCF, LCM is written, right? And HCM is not written, HCF is written. So HCF is highest common factor or highest common multiplier. LCM is lowest common multiplier or lowest common factor, right? Again, નાના છોકરા જેવું વિચારવાનું. વર્ડ લોએસ્ટ લખેલું છે પણ આપણે લેવાનું હાઈએસ્ટ, રાઈટ? So 2, highest is 2, there is no other 2, so I will be taking 3 raised to 1, 5 raised to. Here there are no less and more, so there is no much confusion, but we will be taking some. So 2 2s are 4, 3s are 12, 5s are 60. So if someone asks me what is LCM between 20 and 15, it is 60. Right. So what we are learning? How to find out HCF and LCM between two numbers. There should be two numbers, right? Let us go to other two numbers. 60, 120. These are two numbers, right? First, we need to understand, know, calculate basic principle of arithmetic, right? 2, 30 is left. 2, 15 is left. 3, 5 is up. 2 square, 3 raised to 1, 5 raised to. Let me write down in somewhat big numbers. 2 square multiplied by 3 raised to 1 multiplied by 5 raised to. Let us go to 120. What will be the answer? 2. See, what is remaining? 60, right? So you can write down this, because factorization of 60 in terms of prime is always unique. Rule says two things, કે બધા પ્રાઇમ હોય એ એવું કહે છે કે આ એક જ રીતે બને, બીજી એક રીતે બને નહીં. So once we have written 2, now the answer is 60. So I can write down this 2 into 2 into 3 into. What is my ultimate answer? 2 cube multiplied by 3 raised to 1 multiplied by 5 raised to. Right? Let me find out HCF between 60 and 120. Right? First, highest common. What is important first in this? Common. Right? Now, all are common factors. See, 2, 2. 3, 3, 5, 5. Right. So I will have to write down all. See, in previous question, 5 was common. 3 and 2 were not common. Right. So they are common. What is the word written? Highest. નાના છોકરા જેવું વિચારવાનું, હાઈએસ્ટ કે એટલે લોએસ્ટ લેવાનું, રાઈટ. 3 અને 5 માં ક્વેશ્ચન જ નથી. 3 and 5 is raised to 1, right? Because they are equal, so there is no higher lower. In 2, should I take 2 square or 2 cube?
Squares. Cube.
Why?
Lowest. નાનું લેવાનું.
નાનું કયું છે? Cube is smaller than square. You need to take lower number. 2 is all right. 2 we have taken because it is common, right? Now there are two numbers, 2 square, 2 cube. Now you need to see these numbers. Which is lower? This is lower. Square. You are having in your mind square, but you are speaking cube, right? Alright. So this is 2 square. This is answer. 2 2s are 4, 3s are 12, 5s are 60. Right? So what is HCF between 16 and 120? 16. Common factor. Whenever you see common factor, then even if the name is highest, I will be thinking raised to what is a smaller. Here it was 2, here it was 3, I have taken 2. Let me take LCM. LCM first. I need to write down all factors. So all factors are also 2, 3 and 5. Right? And 3 and 5 is not having any problem. Why? Because both are equal. Right? Now for LCM, what is L stands for lower. પણ નાના છોકરાઓ જેવું વિચારવાનું, આ બેમાંથી હાયર કયું છે? So I will write down 2. Right? So 2 cube is 8. 5 3s are 15, 2s are 30, 2s are 60, 2s are 120. 120 is LCM of 60 and 120. Right? So we know how to find out HCF and LCM. Let me take a somewhat bigger number. $500 and say 750. Right? Let me first factor it. 2. If I do 2, it will be 250 remaining. 250 remaining, so again 2. 125 remaining. Now once 125 is remaining, now 2 will not come. If it is 225 is 25 5s are 5 5. Right. This is 2 square 5, 2 square 5, 750 2. 750 divided by 2. 2 3s are 6, 2 7s are 14, 2 5s are 10. What is remaining is 375. 375 divided by 5 will be 75. Right. See why I know this, I'll tell you. When I write down 750, I know one of the factor will be 10, but 10 is not a prime number. So I am converting 10 into prime number. 5 2s are 10. 5 and 2 both are prime, right? So once I write down 5 and 2, so So 750 divided by 10 will be 75. Right. And what is 75? This you should know. 15 5s are 75. 15 also factor we are knowing. 5 into. So 75 is pending. 5 3s are 15. 5s are 75. So this is 2 raised to 1. 3 raised to 1 and 5 raised to 5 is how many times? Cube. Anything 3 times is cube, anything 2 times is square, right? Now, easy thing. HCF. Alright. Whenever you think of HCF, remember this two words. Common, lower. First, let us take out common numbers. Is 2 over here, 2 over here? Yes. So 2 is common. 5 over here, 5 over here? Yes. Common. 3 is over here. But it is not over left hand side, right? So 3 is not a common number, forget it. Right? First, we have taken out common numbers. Right? Now, if they are equal, the question is easy. If they are not equal, then also it is easy. Say 2. Which 2 I should take in? 2 raised to 2 or 2 raised to 1? Yes, because it is a lower number, right? 2 raised to 1. 5 cube or 5 cube? 5 cube, right? So if there is a problem, then lower number. If there is no problem, if they are equal, you can take any number, right? So what will be my answer? 2 into 5 into 5 into 5. 5 5s are 25, 5s are 225, 225 multiplied by 2. This should be 450. No. 5 5s are. I should do it like this. 5 2s are 10. 5 5s are 25. 25 multiplied by 10 is 250. So what is HCF? 250. Right? Let us go to LCM. You need to remember this. All factor and higher number. First, let us consider this all. So which are all factors? 2, 5, 2 we have taken. 3, 5 we have taken. So 2, 3 and 5 are factors. Right. Higher in 2, which is higher? 2 square or 2 raised to 1? Square. I will write down 2 square. In 5, which is higher? 5 cube or 5 cube? I will write it down 5. In 3, which is higher? There is only 1. So it is 3 raised to. Right. So this is 4. 5 5s are 25. 5s are 125 multiplied by 250. 125 2s are 250. 250 700 into 3. This is 1500 is a LCM of two figures, which is 500 and right. So let me now go to use of LCM and HCF. I am telling you right now only one use. This is not important for examination, but this is important for the thing that why you are learning something. HCF and LCM comes in 1 mark. That is not a reason to learn something, right? Try to understand. I am writing two numbers, 20 divided by 15. right? I am telling you, this is divided by, right? I am telling you, write it down this in a simplest form. Write it down this in a simplest form. 20 divided by 15 is also simple. But instead of 20, I want lowest number possible. Instead of 15, I want lowest number possible. Right? I am first finding out HCF between 20 and 50. 20 and 20, it is 2, 2 into 5, which is a 2 square into 15 is always 3. So 3 raised to 1 multiplied by 5 raised to 1. I want highest common factor. Two things to remember. Common. Is anything common? 5. Number 3. Higher means I need to say low. I am a small child. JK નોંધું કરવાનું. Higher લખેલું તો હું low લઈશ. આમાં તો કોઈ question જ નથી because 5 is only raised to 1. So what is HCF? 5? Yes, how it is helpful, I'll tell you. See, it is HCF between 20 and 15, right? What is HCF 5? Believe me, if I want to make this in a simplest form, I should divide this by 5. 5 threes are 15 and 5 fours are 20. What is the simplest form? 4 by 3, right? You can divide, multiply, add, subtract. You can, whenever this type of thing is there, 20 divided by 15, you can multiply anything in numerator and denominator. You can divide anything in numerator or denominator. Try to understand what I have done. I have divided over here 5. I have divided over here 5. In numerator, I have divided by 5. In denominator, I have divided by 5. So 20 divided by 5 is 4. 15 divided by 5 is... See, instead of 20 divided by 15, I have written this in a simple form. What is the simple form? 4 by 3. Which divisor I used? 5. How to know that 5 is to be used? Because 5 is what? HCF. Alright. Sir, if someone gives me this, I already know that 5 threes are 15 and 5 fours are 20. I need to use which magical figure? 5 to make it in a simplest form. Is it all? But see, the question becomes difficult when it is 500 divided by 750. What was HCF? 250. So this should be divided by 250. This should be divided by 250. And believe me, 250, 2s are 500 and 250, 3s are 750. See, we have got which form? Simplest form. How HCF was useful? To find out what will be the simplest form. If I divide a numerator as well as denominator by HCF, my both the figures will be lowest number possible, lowest integer possible. Without points, which is the lowest integer possible in numerator? 2. Lowest integer possible is 3. But how we came to know? 500 divided by 750. Which thing is to be divided? 250. Which thing is to be divided? 250. And what is this 250? Is nothing but HC. What is this? Use of HCF. How HCF can be, right? We will be doing use of LCM, right? For use of LCM, let me take very two simple figures, 4 and 10. Right? First I am finding out LCM, right? 2 square, 5 2s are 10, so 2 into 5. I am finding out LCM. LCM all and high. Which are all factors? 2 and you should not write down 2 times. 2 is one of the factor. Right. Now I should take 2 square or 2 raised to 1, Ishwa?
Raised to 1.
Yes. Because 2 square or 2 raised to 1?
Square.
Exactly.
Else.
LCM, 2 square, right? It is very easy to remember. Lowest common factor, higher number will be used. Highest common factor, lower number will be used. Absolutely, 2 square. So 2 square is 4, 5s are 20. 20 is the LCM, right? Where it is used, I'll tell you. Suppose there are two numbers, 3 divided by 4 plus say 9 divided by 10. Let me take small numbers, 1 divided by 10. If some mathematical question says this, now believe me, 3 and 1 cannot be directly added and 4 and 10 cannot be directly added, right? Here the denominator should be same, but they are not same. So let us make it same. So how to make it same? I can multiply anything in numerator and denominator, right? So this is 4. What number should I make? Believe me, it is this LCM. Right? If I want to make 4 as a 20, what I will multiply? 4 5s are 20. I will have to multiply in numerator also. You cannot directly multiply in denominator and don't do anything else, right? So this is done. Green color pen is done, right? Let us go to purple color pen. Here also denominator is 10. What I should make it? 20. So this 20 figure is helping us, right? I should make it 20. So 10 2s are 20. 1 2s are. What will be this answer? 15 divided by 20 plus 2 divided by
20.
Now simple mathematics, if this is denominator, I can write down this 15 plus, but if this both are same, and they will be same if we have tried that figure becomes our LCM. See, use of LCM. If I was not knowing that this answer should be 20, I would have not multiplied 5, right? So this is the use. What is the ultimate answer? 17 divided by 20. To solve this answer, 3 divided by 4, 1 divided by 10, what was helpful? LCM was helpful. One of the use of LCM. So we'll be ending this lecture. Today we have learned two concepts. One is HCF and LCM. In the process, we have also learned fundamental principle of arithmetic. Every composite number is having a unit multiplication, unit factor, unit product, unique product of prime numbers, right? These are the 2-3 things that we have done in this particular